Good evening, everybody. Unmute myself, no? Please unmute myself. Yeah. Good evening, everybody. I hope you are able to hear me. If I am audible, just say yes by owning your mic.
Yes, sir. Yes, sir.
Okay. Some of the instructions I want to give before I start the class until everybody joins is that your name, the name that you are putting to enter into the batch should be your name, not your brother's name, sister's name, father's name, mother's name, or some ex name. It should be your name. Okay? Then only we can take the attendance properly. Otherwise, tomorrow you will get a call that why were you absent. So please make sure that your name is correctly entered in the name that you are logging inside. Second is your video that I have already shared in the group also. Your video must be on. If it is on and you are removed out from the group, then don't ask me why they removed you. They will remove you from the group. So video should always be on while the class is going on. There are some more things I want to say. Try to have the maximum interaction. Even though we are joining live online, the feeling that you should get should be same as that what you are getting in the regular class. So please make sure that whenever you have any doubt or any clarification, don't hesitate. You can unmute yourself and say, please sir, excuse me sir, stop sir. You say, here we have proper audio arrangements, we can hear you. Like how in the classroom you can interrupt while teaching, here also you can interrupt whenever you want while teaching. Okay? If I take your name, suppose if I take somebody's name, like I say Raksha, or I say Vijay, or I say Vibhusha, or I say Samiksha, that time you should be unmuting yourself and saying, yes, what happened, sir? Or you should answer whatever question I am asking. It is not like you should be silently sitting there. I hope I am clear. When I am taking your name, you are supposed to unmute yourself and answer to whatever I am asking you. Let the interaction be to the maximum. Another thing, when I am taking your name, please don't leave the group and go. It's going to be lost to you only. I have seen sometimes when we take your name, in fear you are immediately dropping out of the meeting. That is the best thing you can do. Don't do that. Don't drop out of the meeting just because I have taken your name. Be bold enough to face and speak. Nothing wrong in that. And who was the one who joined beginning? Bala sir? The one who was singing song, who was that? Nikhil Paul, your voice is very good, but don't show your talent in this class, man. We were here only when we were hearing to your beautiful voice. Nikhil, please unmute yourself. The song that you were singing was really good, but it is not advisable to sing it while the class is going on, especially with your mic unmuted. So these are some basic instructions I want to give before we start today's class. I still see some people like Vijay, Ranjani, you people have not on the video. So if you are out of the meeting in some few minutes, then don't blame me that sir why you made me to go out, because that is the rule. Rule is your video should be on. Vijay, I hope you are able to hear me. Say by saying yes.
Sir.
Where is the video, man, Vijay?
Sir, I am checking it. It's not working.
Man, you are trying to teach us itself. You tomorrow I'll meet your father and I'll say working, not working. Okay, please make sure that you are live, you are interactive, and you are using this class to the best. Believe me, you will feel after a couple of weeks that this class is even more informative, even more useful, and even more interesting compared to the offline classes. Believe me, you will feel in few days if you are properly with discipline coming for the classes. So I hope you know why we have made this arrangement itself. We are on the verge of rainy season. Tomorrow itself is rain alert, and suddenly their classes will be like not be being able to possible, or many of you will not be able to come because of rain. So please understand the reason of doing this, and you have to get benefited at the end. And syllabus is almost done from our side for most of you, except a couple of chapters maybe. Most of syllabus is being done. So syllabus is done. Now what we are going to do is conduct test series for you and revise all the portions. So we are going to have a revision of all the chapters in physics, chemistry, bio and maths. And today is physics class, right? So as per timetable, today was math, I believe you saw that, but there is a mistake. Not only for today, every Monday you will have physics class, every Tuesday you have math class. That interchange is there. It was wrongly put there as math today and tomorrow physics. Every Monday, physics only will be taking place. Every Tuesday, 6 p.m. will be math class. I'll not take much time, 5 minutes are over. I waited for everybody to join. Now I think almost everybody is here, and now we are going to start the class. So my name is Nilesh, and I hope some of you know me, some of you don't know me. I am going to take physics for you, which was earlier taken by Shrey sir. I am going to take physics, and let us see how it goes. So first, let me ask you a question. What happened suddenly behind me, guys? See, what happened suddenly behind me? Became dark. Be Background is changing. Very good. So it became dark, isn't it? Okay. Okay. Good. Now, what is this? Or I'll ask. Let me ask like this. Yes. Yeah. So in this dark room, what is there in the room? It is a dark room. Okay. Are you able to see anything in the room? No. Why? Because there is no light, isn't it? The moment you switch on the light, what happens? The moment you switch on the light, you are able to see what is there inside the room. Inside the room, we have 3 doors, we have a system, we have a chair, we have computer, and all the other things. So why you are able to see something? It is just because of light. Basically, it is reflection of light which helps to see anything. So how we define reflection? We define reflection as the phenomena of light which helps us to see things around us. If reflection phenomena would have not been there, you will not be able to see anything around you, right? So today's class, I am going to start teaching you light, and we are going to learn what is reflection. Today, if we are able to complete what is reflection, then we will be having refraction class in the next week. So Srinidhi says that some other chapter you have. I understand if you want to learn that chapter, you have to come and learn from me separately for some offline session. I'll teach you. I don't have any problem, Srinidhi. But now this class will go as per the schedule. So today is light, so it will be light only. Okay. If you want magnetic effects or any other chapter, get a time from me. Come and learn from me separately. I'll be teaching that to you. No problem. Okay. Coming back. So first, what is light? You should understand what is light, and most of you will know it is a form of energy that produces the sensation of vision. We are able to see things around us because of light being an energy to help that. Next, yes, light follows rectilinear propagation. I hope you know this, because when you go to higher class, we will say you light does not travel straight, rather light travels in wave. I don't want to confuse you now, but as of your knowledge, your class is concerned, you think light is a ray. Light moves in straight line, and whole chapter of light is based upon that only. We will see light is moving in straight line. But when you go to 12th standard, we have a chapter called as ray optics, and we have another chapter called as wave optics. There you will learn light is not only ray, light can also be treated as wave. Now when the light becomes a ray and when light becomes a wave, that is totally depending upon some factors you will be learning in higher classes. Fine, anyhow. So what is reflection first? Let us see what is reflection. Reflection is a phenomena in which there is an incident ray and it hits a opaque surface, and then it gets reflected with following some certain rules. What is that? The angle made by the incident ray with normal, which is angle of incidence, must be equal to angle of reflection, and incident ray, reflected ray, and normal must lie on the same plane. That is called as law of reflection. Am I right? So first law is incident ray, reflected ray, and normal lies in the same plane, and the second law says that angle of incidence is always equal to angle of reflection. I hope you understand and you remember this. Next, if I tell, then yeah, I have same thing I have mentioned there. And now, what is the meaning of mirror? See, in this chapter we are going to learn 2 things. We are going to learn reflection and refraction. When we talk about reflection, we will talk about reflection by mirrors, and when we talk about refraction, we will talk about refraction by a rectangular glass prism and also by lenses. Refraction is by 2 things in this chapter. One thing is refraction by a rectangular glass prism. Another thing is refraction by a lens, a concave lens and a convex lens. We'll come to that. But first of all, what is a mirror? Mirror is derived from a glass, isn't it? If you take a glass and you silver one side, silver means you do a polishing one side. When I say polishing, don't think how you are polishing your shoes. When I say polishing, it means you are painting one side, then the other side which is not painted becomes reflecting surface, and the surface that you paint becomes opaque surface, isn't it? So when you take a mirror and you silver one side, silver means like a paint, then the other side of the mirror becomes reflecting. I hope you are understanding this. The mirror that you see in your home, where you see yourself daily, comb your hair, put some powder, that is a mirror where you are taking a glass, painting one side by using what chemical? Anybody knows the chemical name which we use for painting the glass? Silver? Yeah, it is also used. Another silver, another is there, another chemical, very famously used chemical. Anybody knows? You can unmute yourself and say, if anybody remembers.
Sand, sir.
Sand. Oh my God. No, 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 no. Anything else? Ammonical silver nitrate. You can write down somewhere. Silver bromide and ammonical silver nitrate. They are the most commonly used chemicals for painting one side of the mirror glass. If you paint one side of the glass by ammonical silver nitrate or silver bromide, it becomes a mirror. Coming back. So, if you see,
Sir, ammonical silver nitrate, sir.
exactly, ammonical silver nitrate. Ammonical silver nitrate. I hope you are able to hear me. That ammonia ammonical. Okay. Ashwath, tell me please.
What the symbol for that, sir?
What is the
Symbol for ammonical silver bromide.
not bromide, man? Ammonical silver nitrate.
Okay, what is the
What is silver? What is nitrate?
AgNO3 twice?
Why AgNO3 twice? What is the valency of silver? What is the valency of silver?
Plus one, sir.
Plus 2.
Is it plus 1 or plus 2?
Plus 2.
Varagav, silver is plus 1 or plus 2?
Plus 2, sir.
Plus 1. Others, Samiksha, what do you say? What is silver? Plus 1 or plus 2?
Plus 2.
Oh, great. The whole class is divided in two parts. Plus 2. 2. It is plus 2. Silver is plus 2. So, silver nitrate will become AgNO3 whole twice. And what is ammonical? NH3 is ammonia. NH4 is ammonium. Ammonium. So, ammonical silver nitrate will become equal to NH3 AgNO3 whole twice. But why are we going into that, man? We are not learning chemistry here, Ashwath. We are in physics, and we should know just the name of the chemical that is used. Anyhow, let us proceed further. So now we should know, or you must know, what are the characteristics of the image formed by a plane mirror. And the first thing you must remember, it is having an erect image which is always the same size as that of the object, the first property. The second property is that the distance of the object from the mirror and the image from the mirror is always same. Am I right? Distance of you from the mirror and distance of the image from the mirror is always same. The third thing is lateral inversion. Most of you would have seen this. When you raise your right hand, it shows you are raising your left hand, and when you are raising your left hand, it feels you are raising your right hand. That is called as lateral inversion. So the third one is lateral inversion. So these are the main characteristics of the image from the plane mirror. I will repeat once again. The image must be erect, it must be of same size, the image must be at the same distance as that the object from the mirror, and the image must be laterally inverted. That are the characteristics of the image formed by a plane mirror. Then comes the spherical mirrors. So I hope most of you know what is the meaning of spherical mirror. Like how plane mirror is formed by a glass. If you have a glass, paint one side, it becomes mirror. Same way, if you have a sphere of glass, like imagine a football made up of glass, and from that football, if I cut a part, so imagine something like this. If you have, I'll talk about convex concave first. Let it be like a football. In this football, I am cutting a part of it. I am taking it out, and then if I am polishing or painting the outward surface, then inward surface will be reflecting. This kind of arrangement is called as concave mirror, where a spherical glass is painted from outside direction, the bulge direction, and the inside is reflecting. Same way, if you take out the part of the mirror and you paint which side? Inside, then the outside will be reflecting. This kind of mirror is called as convex mirror. So, convex mirror, the bulged side will be reflecting. In concave mirror, the inside will be reflecting. Are you getting my point? So, these are different types of mirror, but there is another difference between concave and convex mirror. Whatever light rays are falling on concave mirror, what it will do? It will focus it at one point. If the rays are coming from far, from very parallel rays are coming from far, after reflection it will get converged at a point at focus. So, when it is getting converged, it is called as converging mirror, that is only concave mirror. And there is a mirror which has the ability of diverging light falling on it. If it is diverging, it is called as diverging mirror, also known as convex mirror. So, concave mirror is also called as converging mirror, and convex mirror is also called as diverging mirror. Now, some basic terms, again you must know this. So, if there is a sphere, this sphere will have a center, isn't it? There is a sphere, this sphere will have a center, and the center of the sphere is called as what? Center of curvature. So, what is center of curvature? Center of curvature is the center of the sphere from which the whole mirror has been derived. That is called as center of curvature. So, center of the curvature of mirror is the center of sphere of which the mirror is a part. Next is pole. What is the meaning of pole? Basically, if you take any part of the glass which you have made as a mirror, the center of that is called as a pole. But there is another way of defining pole also. If any ray is passing through center of curvature and it is cutting the mirror, the point where the principal axis is cutting the mirror, that point is also called as pole. So, how many poles a mirror can have? One for this condition, but if I am giving a full glass to you, it can have infinite poles, isn't it? Because whatever line, all the diameters will pass through where? It will pass to center of curvature only, and it will cut the mirror at one point. That point is called as pole. Or we can say pole also as the central part. See, as they have written, geometric center of the spherical surface of the mirror is called as pole of the mirror. That way also we can define. Next is principal axis. The line passing through the center of curvature and the pole is called as principal axis. Now, what is the radius of curvature? Distance between center of curvature and pole. The correct way of saying is distance of center of curvature from the pole. That is the correct way of saying. You know why I say this? You will realize when I talk about the sign convention. Always distance has to be measured from where? From, not left, from pole. Always distance must be measured from pole. That's why I am saying radius of curvature is defined as distance of center of curvature from the pole. So, what is the location of center of curvature? Its distance from the pole is called as radius of curvature. You may also write distance between center of curvature and pole. It's not wrong. But the correct way of remembering is always measure the distance from the pole. So, what is radius of curvature? It is the distance of center of curvature from the pole. Next comes focus. Very important thing, because in lenses we have two focus. When we talk about lenses, I will make you clear what is the difference between this left focus and right focus. But here if I talk, they will have only one focus, whether it is a concave mirror or convex mirror. So, focus, if you see, it is the point at which what happens? The rays that are coming from infinite, the parallel straight lines, if they are converging at a point, that point is called as focus. I hope you are understanding that. If rays are coming from very far, parallel to principal axis, and if they converge at a point, that point is called as what? It is called as principal focus. Very good. And if we take as a convex mirror, then what will happen? The rays will come, it will get diverged, and when the rays gets diverged, that time it appears to pass through one point, and that point is called as principal focus for a convex mirror. I hope you know both the things. Here the rays are coming, getting diverged. If you extend, then it is meeting at a point. That point is called as focus of a convex mirror. The difference is, in the case of, if I write here, one second. Yes. If you see this focus, Is it visible to you what I am drawing? I hope it is visible to you. This focus is formed not by the real intersection of rays, rather it is formed by the imaginary rays getting combined, isn't it? But this focus is formed by the real intersection of the rays, am I right? So, if the rays are really intersecting to form at a point, no, that is called as real focus. So, this focus is also called as real focus. And if the focus is formed by not the real rays, by the extension of the real rays, this focus is called as what focus? Virtual focus. I hope you are understanding this. So, what is real focus? Real focus is formed by which mirror? Concave mirror. Virtual focus by which mirror? Convex mirror. Because here the rays are not really meeting, it is looking to meet, it is seeming to meet. I hope you are understanding this point. That is the difference between the focus of a concave mirror and the focus of a convex mirror. So, coming back. So, next focal length. What is the meaning of focal length? Again, you may say that distance between focus and pole. But what I will say, the correct way of remembering is distance of focus from the pole, isn't it? Distance of focus from the pole is called as focal length. Distance of center of curvature from the pole, that is called as radius of curvature. Same way, distance of focus from the pole is called as focal length. I hope you remember this. And what is the relationship of focal length with radius of curvature? 2f is equal to r. That is, radius of curvature is always equal to twice the focal length. I hope all of you know this. R is always equal to 2f, that is f is equal to r by 2, isn't it? Focal length is always half of radius of curvature. Now my question is to Pranavaditya, if you are there in the class, unmute yourself and say me, this r is equal to 2f, is it valid for lenses also or it's only valid for mirrors?
No, sir.
No means not valid for lenses.
Mirror, sir.
Okay, Srinidhi, what is your opinion? Whether it is valid or not valid for lenses?
It's valid for both.
Okay, you say it's valid for both. Very good. Raksha, what is your opinion? R is equal to 2f. Valid or not valid?
It is valid for both, sir.
Great. Samiksha, what is your opinion?
Sir, for both.
Okay, very good. Sultan, what is your opinion?
Applies for both, sir.
Applies for both. R is equal to 2f applies for both. Okay, good. Vijay, what is your opinion?
I don't think it's good.
Okay, most of you will say it applies for both. Am I right, Sanshita? What about you? No, it is not. This many of you are saying it is correct, so it will be wrong only, no? So definitely R is equal to 2f is valid only for mirrors. Remember this. This question has come in the board exam in past. How question came, you know?
Focus which you take, sir.
Tell me loudly, man.
It depends upon the focus which you take.
But
Lenses.
not like that, not like that, not like that. Whatever focus you take, whether you take the principal focus or secondary focus, it will change only. Let me explain it to you. Please pay attention. The question has come in the board exam like one mirror, that is a concave mirror, and a convex lens. Both are immersed in water. What will happen to the focal length of both? The answer is the focal length of mirror remains same, but focal length of lens gets changed. Have you heard about this question anywhere? Heard? No. Why it is getting changed? Because focal length of lenses are medium dependent, whereas focal length of mirror is not depending upon the medium where you are keeping it. In higher class, you learn a formula for finding focal length. I am writing it here, but not required for the exam. Don't panic. The formula is 1 by, it is red color, I'll use some other color. Okay. The formula is 1 by f. Is it visible to everybody what I am writing on the board?
Yes, sir.
Okay. So the formula is 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. This is for whom? This is for lens. Now this formula is not at all required for you now. Okay, don't think why we are teaching this. I am teaching you to make you understand that the f and r are not related like how it is related in the case of mirrors. Mirrors, we say that f is equal to r by 2. Can I say? Yeah, I can say. But can I say same f is equal to r by 2 in the case of lens? No, we should not say, we cannot say. So remember, focal length of lenses don't behave the same way how it behaves for mirrors. I hope my point is clear. If anybody has any doubt, you can ask me. So f is equal to r by 2 is valid only for mirrors. Remember this. Coming back. So now, ray diagram is one of the most important thing in this chapter. In board examination, expect one question for sure to come where they will ask you to draw the ray diagram for various object position. They may ask you object at between C and F, object at beyond C, object at C, object at between F and P, anything may come. So by now, you should be thorough in all the ray diagrams. By now, you should be thorough in all the ray diagrams. But what ray diagram helps us to do? It helps us to find the position, the size and the nature of the images. For example, if you see this kind of image is erect image, isn't it? This image is looking magnified, isn't it? The hand becomes big. Or if it is becoming inverted, or if it is becoming diminished. These kind of characteristics you can find only if you learn how to do the ray diagram, that is the image formation of various object positions. That's why we are learning ray diagram, to identify what is the position, what is the size and what is the nature of the image. Fine. So first I am going to start with the basic things. See, I know you must know this, but even then I am revising it and I don't know how much you have understood previously. So I am once again revising from very basic level. So what I am going to tell you is how to draw a ray diagram. By now all of you will be expert in that, because almost in the end of the academic year we are. But once again, for some children, I am once again repeating it. So what is the rule or what is the way you will never make mistake in ray diagram? That's why you can see there is line, no? Because in board exam paper also you will get lined sheet. You are not going to get white sheet. Am I right? So what you should do, the correct way is always take a scale, take a pencil and draw a straight line. That all of you will do. After drawing a straight line, you are supposed to, from this principal axis, take 3 centimeter. Now this 3 centimeter, what I am going to tell you is not strictly to be followed, but if you do like that, you will always get some beautiful diagrams. So those who are not drawing neatly, for them this is very important. Note this down. So what you will do, you will take a scale, take 3 centimeter from the rightmost end and mark a point. This point will be the pole of my mirror. Whether it is a concave mirror or convex mirror, it will be the pole of the mirror. Then what I will do, I will take a protector and I will keep my protector in such a way that it's 90 degrees lying on the point P. I hope you are understanding. 90 degrees lying on the point P, and then I am going to draw a curve. Don't draw fully, it look too much like, it look like a bowl. So draw only like between this 150 degree and 30 degree. That is the correct thing. Or you can draw even little lesser than that. I hope you are understanding. After you remove your protector, it will look like this. Some neat diagram. Then what you do the shading. Again, here I have drawn concave mirror. If you do shade inside, it will become convex mirror. It's up to you. What is the question given? That the shading you do. After doing shading, the next step is to take from the pole 2 centimeter. You can, if your paper is big, because in the board exam you are going to get landscape format of booklet. If that is so, if it is landscape format, then you can even take it as 4 centimeter. But if it is the portrait format answer sheet, then make a habit of taking 2 centimeter. Mark a point, focus. Once again 2 centimeter. Mark a point. What is that? Center of curvature, isn't it? Then you can keep the object at various positions to draw the ray diagram. This 2 centimeter can be even taken as 4 centimeter and 4 centimeter if you have enough space. Are you getting my point? I am not sticking to 2 centimeter, but 2 centimeter if it is a small portrait paper. If you are having a landscape like huge paper, then you can take 4 centimeter also. Then start your image formation. Before starting the image formation, you must know some rules. Like I hope you remember, any ray which is passing parallel to principal axis, what will happen to it? It will converge and pass through focus, or diverge and seem to pass through focus. Am I right? If it is a concave mirror, any ray which is coming parallel to principal axis, what it will do? It will converge and pass through focus. If it is a convex mirror, it will diverge and seem to pass through focus. I hope you know this. So if I am drawing any ray parallel to principal axis, I will make it to converge and pass to focus. In board examination, you also have marks for the arrow that you are keeping. Forget to keep arrow, forget half marks. So please don't forget to mark the arrows. Arrows are very important, right? Then comes the rule number 2, where if any ray is passing through center of curvature, it always retraces its path. I hope you know this. If any ray is passing through center of curvature, it will take the same path back. What path it is coming, in the same path it will go back. Okay, I'll ask this to Jyotsana. Jyotsana, if you are able to hear me, please unmute yourself.
Hello.
Yes. So Jyotsana, please tell me why this happens. Why a ray after passing through center of curvature is retracing its path? What is the need of that? Any idea?
No, sir.
Okay, then this question goes to Vinisha. Vinisha, I think for LWA Vinisha. Yes, Vinisha, if you are able to hear me. Yes. Any idea? No idea? Okay. Ashwath, what is your opinion, man?
Sir, it falls perpendicular to the mirror, so it bounces back in the same path.
What is perpendicular here, man? And anything is looking perpendicular to you?
Perpendicular to the mirror.
So do you think that this line is perpendicular to the mirror? You think you say like that?
Yes.
Okay, okay, I'll come back to you. Good try. Sarah, if you are able to hear me, can you give a try? Sarah, if you are able to hear me, the question is for you. Any idea why that ray is retracing its path? That's, you should. You don't know? Good. Okay. Sushmita, if you're there in the meeting, please unmute yourself and tell me, what do you think the reason for ray to retrace its path? Okay, let me tell the answer now. So see, huh? Why it will act as a radius?
Because it is coming from the center of curvature.
So,
So it will be perpendicular.
okay, that's why. Okay, good. Something what you think is correct. Always remember this point. Any ray which passes through the center of curvature and touching the mirror is like radius, that what he said. It's the Ramcharan said, it will be like a radius. Or you can say that it is perpendicular to the mirror, because if you remember your 9th standard, you must remember that radius is always perpendicular to the tangent drawn at that point, isn't it? If you draw a tangent, then radius is always perpendicular to tangent. Anybody has doubt in this? 9th you studied this, no? Not studied in 9th or 10th you studied this. Okay, whenever you studied somewhere, no? This is math. That radius is always perpendicular to the tangent of it at that point. So, if any ray is passing through radius, if any line is drawn through radius, it will always be perpendicular to that point. And that is the reason this point is perpendicular. What is the meaning of being perpendicular? See, whenever there is an angle of incidence, please pay attention. Yes, this is angle of incidence, then we get a reflection, it is angle of reflection, and they both are equal. If the ray itself comes in which path? On the normal itself, then angle I became 0. If angle I became 0, angle R becomes 0. Are you getting what I am trying to tell? That's the reason when the ray is passing through center of curvature, it is undergoing normal incidence. Remember this word. It is called as normal incidence. What is the meaning of normal incidence? If the ray passes through the normal, the incidence is called as normal incidence. In normal incidence, angle of incidence is 0, and so angle of reflection also will be 0. If angle I and angle R both are 0, obviously it will take the same path. The same thing happens in this also. If the ray comes straight, it will go back straight. Isn't it? I hope you are clear in this. All of you understood now? Why is the ray retracing its path? These questions have come and you should be very clear in these concepts. Once again, you are going to have this chapter in 12th standard, don't forget that. If you are going to take science, if you take commerce, you can get rid of it. Okay, anyhow. So, next topic.
Sir, can you repeat this concept again?
Very good, I erased the board. Yeah, I'll repeat it. So, I said that whenever a ray is passing through the center of curvature, that ray is perpendicular to the point where it intersects the mirror. Is this clear to you? I'll repeat. Whenever any ray is passing through center of curvature, it is always perpendicular to the point where it intersects the mirror. If that happens, then something like this you can imagine. This becomes perpendicular. Now the ray is also coming on the same path, then the angle I will become equal to 0. If angle I will become equal to 0, the ray will go in the same path because angle R is also equal to 0. Are you understanding this?
Yes, sir.
That is the reason for the ray to undergo or retrace its path if the ray was passing through center of curvature. Okay. The third rule is the vice versa of the first rule. The first rule says that ray is passing parallel to principal axis. It will converge and pass through focus. So, if the ray is going to pass through focus, it is going to become parallel to principal axis. This is called as the third rule. First rule, third rule are just vice versa of each other. And the fourth rule, the least used rule by students, is that if any ray is passing through pole, it will follow law of reflection. It will make the same angle as the angle of incidence and it will go like this. So, whatever is the angle I, the same will be the angle R. If you are drawing 20 degree, it will go 20 degree, 30 degree, it will go 30 degree, isn't it? Out of these four rules, any two rule you can choose for the image formation by the mirrors, concave as well as convex. Whatever image formation you are doing, what you need is any two rules out of these four rules, because two rays are enough to find the position of the image. I will tell you that also how. So, now comes the main part of this topic chapter, where we are going to learn what will be the image position, image size and image nature when we are going to have object at various location. Please be connected. I am going to ask questions to you. I will take your names, even you people, and I will ask you questions based upon what I am going to revise now. Again, this is a very known topic to you. You must remember all this. So, first is object being placed beyond C. So, if the object is kept beyond C, you know how the image formation takes place. The first ray I will be drawing where? Parallel to principal axis. It will go and pass through focus, isn't it? The first ray I draw parallel to principal axis, it will converge and pass through focus. I hope you know this. Then I will take second ray. My wish, I can pass it to focus, I can pass the center of curvature, or I can pass through pole. I have three options. All three options will give the same image for, position. Your wish. Whatever suits you, do. The most commonly used rule is passing through focus only. The head of the image. Now, see what we do conceptually. If I tell you, we take the head of the object. Are you able to see this? We take the head of the object, and if you see the object, you will realize that this is perpendicular on the principal axis. Am I right? So, what we do? We just find the head of the image, and once we get the head of the image, we will just draw perpendicular line. We will get the image location. This is the concept. From the head of the object, I take two rays and I will see where they intersect. Wherever they intersect, that is the position of head of the image. And once you get head of the image, from there if you draw perpendicular to principal axis, you get the image position. Is it clear to you? Not only here, in all the ray diagrams, same thing we are going to do. We will take the object, head of the object, draw two rays and see where they are intersecting. Again I am repeating, you can use any rule. First rule, second rule, third rule, fourth rule. It will meet in the same, like for example, now if I show you, if I would have taken passing center of curvature, see, it is going to meet in the same point, isn't it? If somebody is taking passing through pole, it is going to meet in the same point. See, all the four rays are meeting in the same point, whether it is passing parallel to principal axis or passing through focus or passing through center of curvature or passing through pole. All the four rays are meeting in the same point. So there is no hard and fast rule that you should use only first rule and third rule. You can use any two rule. Are you getting my point? So it's going to give you the image. And if you draw the image diagram very properly, neatly, that itself will speak to you its nature, its size, isn't it? You can see very clearly here it became diminished. It became diminished, and where it is formed, the image is formed between C and F. Some children have the thinking that between means in the center. No, I am not saying in the center of C and F. Between, anywhere it can be. It can be here, it can be here, it can be here, anywhere it can be. Okay. So what is the nature of the image? First thing, real, obviously inverted, and then it is diminished. And where is the position? Position was between C and F. Am I right? I hope it is clear to everybody who is there in the class. Next, what I will do, I will make the object to go more nearer, and I will draw the object at C. If the object is at C, then obviously I will take the first ray passing parallel to principal axis, converging through focus, and second ray I will take passing through focus and becoming parallel to principal axis. Once again, if you have used that technique of taking 3 centimeter, 2 centimeter, 2 centimeter protector for drawing the mirror, then only you will be getting neatly at C. Randomly drawing by hand, drawing 1 centimeter, 3 centimeter here and there, then what will happen, your image will not meet at C. Are you getting? You will think I kept the object at C, but the image is not coming at C, image is coming somewhere else. What mistake I am doing? What mistake you are doing is you are not drawing the ray diagram properly. Ray diagram means first drawing a principal axis, going 3 centimeter apart, taking protector, drawing or taking compass, drawing a proper curved concave or convex mirror, then keeping the 3 or 4 centimeter or 2 centimeter and keeping the object at the 4 centimeter point, drawing one ray, passing like this, drawing another ray, passing, it will definitely meet at center of curvature, believe me. But many of you would have faced this problem by now, not getting the image diagram properly, only because of your poor handwriting, poor presentation, and negligence towards drawing. If you are aiming for 100 mark, then these things are going to play a role. If you are aiming for 90, what is more than that I need? Then problem, no problem. What you are doing is enough. But if your aim is 100, then you must be careful about each and every small thing. Coming back. So next is its nature. So its position is same at C, real, inverted, same size. Obviously, I hope you know and you understand, real, inverted, same size, fine. Then I will make the object to go more inside. First I kept beyond C, then I kept at C. Now I am going to keep between C and F. If you keep between C and F, then you are going to get the first ray passing parallel to principal axis, which is passing through focus obviously, the second ray passing through focus, becoming parallel to principal axis, and where it meets, you can see it is meeting beyond C. It is real because rays are really meeting, inverted, enlarged, and obviously position is beyond C. So beyond C, real, inverted, enlarged. Do you agree with me? I hope you agree with me. Then its nature is the same thing has mentioned here, beyond C, real, inverted, and magnified, enlarged, whatever. Next comes object at focus, very important, because people do mistake here. What mistake they will do, they will keep the object at focus, and the first ray they will take parallel to principal axis, it will pass through focus only, no issues. Second ray they will try to pass through focus, it will go straight down, they will confuse what to do. Don't use that rule. What you can do then, you can make, you can make the ray to pass through center of curvature. Are you getting my point? Or you can make the ray pass through pole. There are 4 rules. Why are you depending only on one rule? You can make it to pass through focus pole like this. Then also it will become parallel to this ray, or as drawn in this, you can make it to pass center of curvature. Both way if you do, you will feel that rays are meeting, not going to meet, and it's going to go very far. So we say it is going to meet at infinite, and it will be real, inverted, and highly enlarged. Real, inverted, and highly enlarged. Why we say infinite? Because it never meets this side. That's why we say infinite. Infinite means literally very far. Then if you ask me, then what is the meaning of this, sir? They never meet itself. Then will the image form? Yes, image will form, but it will be like you will not be able to make any screen to capture the image. Okay. First of all, do you know that all the image that we have formed till now, when the object was beyond C, object was at C, object was between C and F, now object is at F, all these scenarios, whatever image we have formed, it is a real image. Image being a real image, you must need a screen to capture it. I hope you know this. We cannot capture the image in the mirror. So screen has to be placed, right? For the case of object at F, wherever you keep the screen, you will not be able to get the full image of the object. That is the meaning of at infinite. Image will form, like for example, I am the object, then half of my body will come, little more will come, little more will come, little more will come, big form of me will come, highly enlarged, but I will not be able to get my image in the full size screen wherever I keep the screen. That is the meaning of image forming at infinite. Are you getting my point? Is it clear to you?
Sir.
Yes. Then let us go to the next image diagram where the object is kept between P and F. So if it is kept between P and F, then first ray passing through focus, that is parallel to principal, pass through focus, and second one, once again I will take passing through center of curvature, or maybe, I mean, your wish. If you take passing through center of curvature, then you will see that it is getting diverged here, but when I go to extend this in the virtual side, then I will see it is forming an image inside the mirror. I hope by now everybody knows what is the difference between a virtual image and a real image. In real image, you need a screen to capture it. I cannot capture the image, I don't have a screen. But the virtual image can be seen inside the mirror itself. Like you see yourself in the mirror at home. What is that mirror? What is the image? Virtual image, plane mirror, virtual image. But if I am having a concave mirror and my image is forming somewhere beyond C, I will not be able to see myself. Mirror is there, I am standing in front, but I am not visible inside. Because where is the image forming? Somewhere else. There, if I keep a screen, I will be able to see myself inverted there. But if for a concave mirror itself, if you move and stand between P and F, no, then you will be able to see yourself inside the mirror. Are you getting my point? But you will be having enlarged version of yourself. See here, what is the nature? It is magnified, isn't it? So if I am having a concave mirror in front of me, if I am standing far from it, first when I see myself, I will not be able to see myself. When I go more nearer, I will not be able to see. More nearer, I am not able to see. If I go too nearer, I will be able to see. It means what? I came between F and P. And I will be able to see a magnified version of myself. Are you understanding? If you are given two mirrors, one is concave, one is plane. Without touching, you should say whether it is concave or plane. Then in plane mirror, wherever you stand in front of the mirror, you will be able to see yourself inside. But in concave mirror, only after a certain distance you can see yourself inside. Otherwise, you will not be able to see yourself inside itself. And second thing, you will be seeing yourself as a bigger version of yourself. Magnified image will be formed. I hope you are understanding this. Sure? Okay. And then the last case, when the object was placed at infinite. If the object is placed at infinite, then what will happen? The rays will come parallel to principal axis. It will converge and pass through focus. So image will be formed at focus itself. It will be highly diminished. Obviously, rays are really meeting, so real, inverted, and highly diminished. Is it clear to you? So all these ray diagrams where the object was beyond C, at C, between C and F, at F, between F and P, we saw the image formation. If I draw all these diagrams in one single diagram, See, it's very important what I am going to do now. So, be focused. I am having a concave mirror. Okay. So, since I said concave mirror, I am going to draw the polishing like this, and I am going to make a principal axis, and I am going to plot focus, I am going to plot center of curvature. First, I am keeping the object at very far, so I am writing it as at infinite. Second, I am keeping the object beyond C, same object. Third, I am keeping the object at C. Fourth, I am keeping the object between C and F. And fifth, I am keeping the object at F. So, for all these five cases where the object is at infinite, beyond C, at C, between C and F, and at F, where will the images form? You can see if the object is at infinite, image will form at the focus. Am I right? So, I am writing it as 1, but in red color. Red color is image and green color is object. When the object is beyond C, the image will be coming diminished, but it will be between C and F, real inverted. If the object is at C, image will also form at C. It will be same size, real, inverted, at C. If the object is between C and F, the image will go beyond C. It will be real, inverted, enlarged. If the object is at F, image will form at infinite. It will be real, inverted, and highly enlarged. What you are understanding? You are understanding that if the object is moving from where? From infinite to focus, then my image moves from focus to infinite. Are you feeling that? And as the object is coming near, the image is becoming big and bigger. Highly diminished, same size, enlarged, highly enlarged. Are you seeing it? So, as the object is coming towards the mirror, towards the focus I should say, then the image will go where? Away from the focus towards infinite. So, always remember this. When the object is moving from infinite to focus, image moves from focus to infinite, and it is going on becoming bigger. So, concave mirror has the capability of producing all kinds of images, that is diminished, highly diminished, enlarged, highly enlarged, same size, isn't it? Not only that, if you keep the object where? Between P and F, this was P, right? So, between P and F, the same object I am keeping here, 6th position, then where will the image form? Image will form inside the mirror. Yeah, inside the mirror, it will be virtual, erect, and enlarged. So, concave mirror is also capable of forming a virtual image, but it will be enlarged image. Are you getting my point? I hope it is clear. Sure? Anybody has any doubt up to now? No doubt? Sure. Okay, I'll take 2 minutes of time. I think shall I erase the board? Can I erase this board? Can I erase this board?
Yes, sir.
If anybody wants me not to erase, please say don't erase. Okay, so I'll erase the board. Nobody said don't erase. Right. Now the question is to Kanishka. Sorry, Kanishk, that boy whose video was off till now. Yes, Kanishk, you are able to hear me? Yes, Kanishk, tell me, the question is for you, that if the object is at infinite, where will the image be? Tell fast, Kanishk. Kanishk, there or you left the meeting? This will happen when I ask. Yes, Kanishk? Behind the mirror. Very good. Ajay?
Sir, I focus.
I told Ajay, Vijay told. Okay, fine. Anyhow, Ajay, Vijay are okay. So it will be at focus, Vijay, correct. And where will what will be the size of it, Vijay? Vijay now, Vijay.
Extremely diminished.
Yeah, highly diminished. And nature?
Real and inverted.
Obviously, real and limited. Good. So next question is to Bhupesh Haran. Bhupesh, fast, fast, fast. Object at focus. Tell me, where will the image be? Infinite. Very good. Size?
Size of the image enlarged.
Highly, wrongly written there. Highly enlarged it will be. And nature will be real inverted. Okay. Next is Bhavin. Bhavin, you are able to hear me? Fast. Say yes, man. Bharatraj, if you are hearing me, fast. Yes, Bharatraj. Object is beyond C. Where will the image be?
Between C and F.
Okay. What is the size?
Diminished, sir.
What is the nature?
Real and inverted.
Okay. Ramcharan, if the object is kept between C and F, what is the position? Beyond C. Size? And diminished? Enlarged. And nature? Yes. Ovia Shri, object is at C. Yes, fast, fast, fast.
At C,
Very good. Size?
same size,
Very good. Nature?
real and inverted.
Yes. Nikhil Paul, the singer Nikhil Paul.
Sir, why, sir?
Why, sir? Because you sang song, man, before entering. Am I saying wrong?
I didn't notice. My
Oh.
was
Okay, man. Singer saying is, I'm not scolding you. Singer is a compliment only. Why are you taking otherwise? Okay, anyhow.
okay, sir.
So, object is between P and F. Pole and focus.
Behind the mirror.
Very good. Size?
Side, virtual.
Size, man.
Sorry, virtual.
Virtual reality is nature, man. Size, magnified. Yes, good. Magnified, correct. Okay. I hope you have understood whatever I have told now, isn't it? See the question. Question is to everybody who answers first can think they are lucky. The question is, we wish to obtain an erect image of an object using a concave mirror of focal length 15 centimeter. What should be the range of distance of the object from the mirror?
Below
Ze-
15.
0 to 15. Nature of the image. Nature of the image.
Virtual and erect.
Already wrote the erect itself wrote, then it will be virtual only, yes. Is the image larger or smaller than the object? How diminished here? Concave mirror virtual will be always enlarged. And you can draw the ray diagram easily, isn't it? So, yes, next question. This question is to anybody. First, from the given table showing object distance and focal length of the three concave mirrors, answer the following questions. Answer the following questions. So, object distance is given, focal length is given. Out of three, in which case the mirror will form the image having same size and object, huh? Third case. What is your answer? Ramcharan? Object distance is given, focal length is given. They are asking in which case it will be having same size. They are saying third case. Obviously a third case. Object at 20 means it is at center of curvature, right? Then only you will have same size, no? Are you getting what why the answer is? Obviously, third case, case 3. Fine. So, last topic of today's class is uses. Most of you will know uses of concave mirror. If you go for shaving, nowadays we don't go for that kind of place. If you go, earlier they used to have mirror and they will see, okay, properly shaved means they will have the concave mirror. Because it will show larger, you can see, okay, here shaving is remaining. 1 second shave you will say. And second is the headlights, because headlights, it will make the beam powerful. Okay, we will talk about this topic in the next class, because if I start talking now, time is already up, other students are waiting. So, we will meet again in the next Monday's class, where I will continue my topic of teaching you light and ray diagrams are over. Now, I will teach you what are the mirrors formula, magnification formula and numericals based upon that. Very, very important part of this chapter, which I will be teaching in the next class. Don't forget, every Monday you have physics class and every Tuesday you have math class. In the timetable sent in the group, it was wrongly mentioned as Monday math, Tuesday physics. Actually, it is ulta. Monday physics, Tuesday, math. And whenever you are coming to the class, once again I am repeating, camera should be on, you should be interactive, and I hope things today would have gone fine. If there is any problem, please give me a feedback after the class in the WhatsApp. Thank you very much for attending the class. Take care. Bye-bye. Good night. We'll meet again in the next class. Take care.